Welcome to You Can Do It Maths. As you can see here, today we're doing the February-March 2022 paper 22. This is going to be awesome. Question 1, simple measuring the angle. Make sure you get the basics right, that the middle of the protractor is in the middle there. Make sure you have a 0 on the line. Okay, look at the 0 because we have the inside 0 on the line. We're using inside numbers, and it's pretty clear that our angle is 40 degrees. Question 2, calculated question. Make sure you slot this in correctly. We put square root 5. Use the side arrow to move away from underneath the square root. Okay, what would be wrong is to continue typing, and you see that square root is over the 6 squared. That is wrong. Okay, so use the side arrow. Make sure the square root stops there. Put 6 squared equals. Okay, and let's write down the whole answer. That is 80.498, etc. Rounded to 2 decimal places would be 80.50, as after 49 comes 50. Okay, that 0 being optional, but it shows it's been rounded to 2 decimal places. Question 3, a journey starts at 9:15 one day and ends at 4:33 the next day. Calculate the time taken in hours or minutes. Best method here is to jump. Okay, let's first jump to the nearest hour. That will be 10 o'clock at night. So that is 45 minutes. Then let's jump to midnight, which is 000 or 24, which is another 2 hours. Then we can jump to 4 o'clock in the morning, which will be another 4 hours. And then we jump another 33 minutes to 4:33. Okay, let's add that up. That gives us 6 hours, and 45 plus 33 gives us 78 minutes. Okay, of course, that makes up a whole nother hour. So if we subtract 60 from that and add the hour there, that will give us 7 hours and 18 minutes. Question 4, you might think it's silly, but the most common mistake in the exam is working out the volume instead of the surface area. Okay, remember surface area, there are 6 faces. We need to work out the area of each, starting with the front face. This one here, it's got a length of 7 and a width of 5, so that's 7 times 5. Now the back face, of course, it's got the same, so we can just double that, multiply it by 2. Next, we can do the side. Let's do this side here. As you can see, it's got a height of 5 and a length of 4, so it's 4 times 5 for this side. And then, of course, the other side, the left-hand side, is the same, so we can double that answer. Last, we have the top face. There it is. It's got a length of 7 and a width of 4, so that will be 7 times 4. And of course, the bottom face is the same as the top, so we double that. And that's what we can hammer in our calculator to save time. And then it's always good to double check your answer. Do it twice, because it's very easy to press the wrong button and get the wrong answer. The correct answer here being 166. Question 5, the gradient of a line. Remember the standard form y equals mx plus c, m being the gradient. So all we need to do is just write just 5. Okay, not 5x, 5. Find the coordinates of the point where the line crosses the y-axis. Now what's important to remember, if I've got the y there, the x there, what do we know on the y-axis? This is 1, this is minus 1, x equals 0 on the y-axis. So all we need to do is change the x for 0 there. 5 times 0 is 0, so y is 7. Okay, and as we just said, when we cross the y-axis, the x coordinate is 0, so we put 0, 7. Right, it clearly says here using a ruler and compasses only, construct a triangle. It says clearly leave your construction arcs. It's amazing how many students still try to erase them. and it tells us that already drawn a 12 centimeter line. So read the information carefully, because students do miss these things and do make mistakes. So our first step would be to draw this 9.5 centimeter line. Doing that with a compass means you take your compass and you open it up exactly 9.5 centimeters from the sharp tip to the tip of the pencil. Okay, take your time, get this exact. There we go. And then putting lots of pressure on the sharp end of the compass and only light pressure on the pencil itself using one hand to make an arc like that. Next will be the 8 centimeter side there. Again, take the ruler. Now open the compass exactly 8 centimeters. Go. Put the sharp end at the end of the line. Lots of pressure here, a little bit of pressure there. Using one hand, make a nice clear arc. There where the two lines cross, that will be the top of our triangle. So we can just connect ends of the 12 centimeter line to where they cross. Be exact. Use a pencil so you can erase any mistakes. That's it. Let's check if it's right. That should be 9.5. Brilliant. And that should be 8. You can be 2 millimeters off of this. Don't erase these arcs. And you've done it. Question 7. Write down an inequality. Remember, inequalities is those crocodiles, bigger than, smaller than. Alright, so first let's write down where we got here. We got a -1. We need to write number n in relation to that. We are going to the right, so n is bigger than, -1 is smaller than, and because it is just a circle, it's not filled in, it does mean we do not include the -1, so there's no line underneath, no line there. -1 is less than n, or n, if you want to swap it around, you can write n is bigger than -1, either way around. Question 8. First, on the grid, draw an image of A after reflection in the y-axis. So make sure you use the y-axis, not the x-axis. That's the most common mistake. Okay, each point should be the same distance to the mirror line, which is the y-axis, on the opposite side. So this corner here, 1 square away there, will become 1 square on the other side. So we go over there. This corner here is 1, 2, 3, 4 squares. So we got 1, 2, 3, 4. Over there, and the top one, 1, 2, 3, goes 1, 2, 3 over there, and we connect the points, and we have a perfect reflection. For the translation, remember the top number tells us left or right. If it's negative, we go to the left. The bottom number tells us up or down, and if it's negative, we go down. So get a tracing paper, ask for one in the exam, trace the shape. First of all, we go 3 spaces to the left, so 1, 2, 3, and then 4 squares down, 1, 2, 3, 4. Mark the corners and use your pencil and your ruler to connect them. Question 8b, describe fully the single, very important, single transformation that maps A onto B. So obviously it changes size, so it has to be an enlargement. That is the first mark, writing enlargement. Second, let's look at the scale factor. We're going from A to B, so it's getting smaller. That means we'll have a scale factor that is a fraction, not negative. This is very important. Okay, smaller doesn't mean negative. Smaller means fraction. So let's have a close look. All right, if I look at the height of this, the perpendicular height, this is 4 squares. and the perpendicular right here is 2 squares, so it's got exactly half in distance. So we can just write scale factor is a half or 0.5. Don't put a minus. The last one will be the center of enlargement. So for that, we connect the sides. Be very accurate. Use a ruler and a pencil. That line is too short. And they should all come together in the same spot. Okay, so our center of enlargement there along the corridor is 9. Down the stairs, -1. Okay, just to say again, a negative enlargement means the enlargement would have been on the opposite side of the center. So for a negative enlargement, this B should have been over here and flipped over. Okay, that's why it's just only a half. And you've done it. Question 9, factorization. One way to do this thoroughly is think of the factors of 12. That could be 3 and 4, and a cubed means a times a times a. Factors of 21, 3 times 7 times a, and then we just put the common factors. See, they both have a 3, and they both have at least one a. So that is what we will factorize out. We will have the 3 and the a in front of the bracket. Inside the bracket, we'll put what's left, 4a squared minus, and there's only a 7. Okay, so make sure you factorize fully, and you get every factor there is. Question 10a, sequences. First, writing the first 3 terms. So for term 1, we'll put a 1 where the n is, so that's 1 squared plus 7, which is 8. For term 2, put the 2 instead of the n, so that's 2 squared plus 7, that will be 11. And for term 3, that goes over with 3 squared, which is 9 plus 7, 16. Next one, find the nth term. First, we look at the term-to-term rule. In this case, we are subtracting 8 each time. That means it's n minus 8, right? No, it's not n minus 8. There's lots of students still write that every single time. Okay, it will be minus 8n, because what we have here is the minus 8 times table, which goes like this, minus 8, minus 16, minus 24. Instead of that, though, we got 15, 7, minus 1. So how do we get from minus 8 to 15, or from minus 16 to 7, or from minus 24 to minus 1? We have to add 23 each time. And that's what we put at the back, add 23. Another way to do this is continue the sequence the opposite way. Get the 0th term, that will be 23, because 23 minus 8 is 15, and that is also helps you to get that last term. Question 11, this is talking about a scatter graph. When imagine scatter graph, we got temperature on the one axis, and you got ice cream eating ice cream sales on the other axis, and it says as the temperature goes up, the more people eat ice cream. As the temperature is low, the less people eat ice cream, and that is called a positive correlation. Okay, we're not talking about proportion here. Correlation is in terms of positive, negative, or no correlation. Increase, more is the 2 keywords there, and you've done it. Question 12, Sanjay invests some money. Well done, Sanjay, good idea. And the important thing here is that he's doing simple interest. Remember the formula for simple interest. The interest equals the principal, the original amount, times R, the rate, the percentage, times T, for how long, divided by 100. So in this case, the principal, the original amount he invests, 700. The rate, 2.5%. And the time period, 6 years, divided by 100. And let's have a look. So that will be 700 times 2.5 times 6 divided by 100, and we get 105. Now this is where you really need to read the question very carefully. It says calculate the value of his investment. Okay, this what we calculated is just the interest. This is just the extra money that the bank gives him for investing money there. Okay, his value is not $105 because who wants to have $105 after 6 years when you put $700 in the bank? You want more. Okay, so we need to add it together to get the answer of 805. That is the value of an investment. That's why he put the money in the bank in the first place. Question 12b. We are now doing compound interest. So remember the formula for this. A, the amount, which is different from here, the interest, equals P, again, principal, the original amount, 1 plus the rate, divided by 100 to the power of n, which in this case is t, which is time. So let's see, let's put in there what we have. Right, we got Mira, she invests 700, original amount, at a rate of R, we don't have that, okay, for 17 years, and then her investment is worth 1,030 and 35 cents. So we're going to have to do some algebra here to solve that. So first thing I would do is take this 700, which means times, and divide it. Okay, so that will give us 1030.35 divided by 700 equals then all of this to the power of 17. Next would be to get rid of that 17. So that will be root 17, 1030.35 over 700 equals 1 plus r over 100. Okay, I think it's a good point here to work this out. So to put in that root 17, we press shift and that button there. That means we can put in any root now. I can put in 17, use my arrows to put in the fraction 1030.35 over 700 equals. Okay, and we recognize this as the multiplier 1.023. Okay, to recognize that is what you multiply it. But to help us, we can move the 1, so we can put 1.023 minus the 1, and then we can multiply the 100. So all of that times 100. So from that we subtract 1. That just gives us the increase in percentage, times it by 100, and there we go. We get R, the rate, equals 2.3%. And that's the answer. Question 13 is all about indices. The first one, remember the first rule of indices. When we're multiplying with the same base number, we add the indices together. So that is simply h to the power of 7. Next one, according to the examiner's report, was one of the least successful questions, one of the hardest questions in the paper, but it's actually quite straightforward. So remember, anything in brackets to the power means everything is to the power of minus 3. So we can write it as 7 to the power of minus 3 over x to the power of minus 3. Okay, so first of all, let's deal with the top part. 7 to the power of minus 3. If you're not sure what's going on here, put in your calculator and look at that, okay? The negative means it goes below the line, so basically it means 7 to the power 7 cubed rather, which is 343 as it tells us on the calculator. Okay, the next rule of indices, remember, if we've got anything as a denominator, we can write it as a negative power like that. So we can write x to the power of minus 3 to the power of minus. So we can, basically what we're doing there is we're putting two negatives. We take that negative up there, but we also change it to a negative because that's what we need to do. Two negatives makes a positive, and that's our final answer. X cubed over 343. Question C. Remember the next rule about indices. When we are dividing with indices, it means we subtract. So we can write it like this. Okay, now because these two base numbers is the same, a equals a, it means the indices equals each other. 8 minus p equals 2. So 8 minus p equals 2. Okay, move the 2, swap the 8 in the 2, yeah? So the 2 becomes minus, the p becomes positive. 8 minus 2 is 6, or 8 minus 6 is 2. So p must be 6. And we've done it. Question 14 is very straightforward. Circumference of the circle. Remember, there's two formulas. C equals pi d, or C equals 2 pi r. So remember your formulas here. They give us the radius, so I'll use the second formula. So the circumference equals 2 pi times 4.7. Let's put that into our calculator. And we get 29.5309, etc. To three significant figures, 29.5. Question 15. Without using a calculator, it simply means if we just do it with a calculator, 2 or 1 over 3 times 11 over 14. Using the calculator, getting the answer as a mixed number, we can change it by pressing shift. 1 and 5 over 6. That is the correct answer, but we're not getting any marks because we used our calculator and we didn't show all the working. Okay, so to get full marks, let's start showing the working. First, change 2 and 1/3 to a mixed fraction. So 2 times 3 is 6, plus 1 is 7 over 3. If in the exam, for any reason you forget how to do this, you can consult your calculator. Put it in, press equal, it's done for you. Right, next, remember, when we're multiplying with fractions, it's easy. We multiply the top with the top. 7 times 11 is 77, and the bottom with the bottom. 3 times 14 is 42. Then we simply have to simplify that. I think we can divide both by 7. That will give us 11 over 6, which we then, if we change it to a mixed fraction, is 1 and 5 over 6. There's another way you could have done this. You could have simplified before you have multiplied. So you divide 7 here, that gives you 1. Divide 7 there, that gives you 2. 1 times 11 is 11. 3 times 2 is 6. That's another option. That is showing all your working. And now you can get your marks. 1 for changing to the mixed fraction. 1 for doing the multiplication correct. So either one of these steps. And 1 for writing at this mixed number correct answer. Question 16, they give us 2 points and they tell us to find the equation in y equals mx plus c. So they help us quite a lot there. So let's think about what is y equals mx plus c. Well, first of all, let's draw the actual line that goes through those points. There we go. Okay, now remember, in y equals mx plus c, the m is the gradient. Now we got 2 ways to find the gradient here. We can look at the rise over the run. So let's make ourselves a right angle triangle. Count that 1, 2, 3, 4, 5, 6, 7 squares going up. 1, 2, 3, 4 squares going sideways. No, it's 8 squares going up. Sorry, yeah. Make sure you count this right. 8 squares going up. Okay. Also, another thing to notice, the line is going down. So, of course, there's negative. So you can say as it's going down, 8 squared is minus. So we know the gradient then is minus 8 over 4, which is minus 2. If you prefer to use the formula for the gradient, of course, is the change in y over the change in x. Okay, so in this case, if we make that x1 and x2, y1 and y2, we'll have y2 is minus 3, minus 5. And x2 is minus 2, minus 6. No, that is wrong, of course. Minus 2, minus 6. Minus 3, minus 5 is minus 8. Minus 2, minus 6. 2 negatives is a plus, is minus 2, plus 6 is 4, we get the same gradient. So we can write that minus 2x got the gradient. Next is to find the y-intercept. And then by drawing my line, we can just see it. It's minus 7. Easy as pie. Question B, find the equation of a line that is perpendicular and passes through the origin. They helped us a lot here by giving us actually this sketch. That makes it really easy. Okay. So let's draw a perpendicular line that goes through the origin over there. Okay. Look something like this. Okay, now reading the gradient of this line is going to be a little bit harder. My line is not that exact. Okay. But first of all, let's do the gradient. So we want y equals m. What is m? Now, if you remember, first of all, we look at that line where the blue one is negative, the green one is positive. And then we can also invert the gradient. So when we had a gradient of minus 2, we can put it as minus 2 over 1. Okay, so the previous gradient is minus 2 over 1. For the new gradient, we need to invert it and change the sign. So that will be a half. Okay, if my line is good there, that will be easy to see. I think my line is a bit easy. That should be 2, and that should be 4. So we'll have 2 over 4, which is a half. Okay, so again, they want us to write the equation. You start with y equals, we got the gradient a half x, and the next thing is the y-intercept, what comes at the end. Where does it cross the y-axis? At 0. So you put the plus minus 0, or just leave it blank. That's also fine. And you've got it. Question 17, I think it's important that we talk strategy here before we attack this question. First of all, they want to know the percentage of the shaded area. So remember, to work out percentage, we're going to have to find the shaded area divided by the total area times 100. Okay, but now working out the shaded area looks a bit longer than just working out this part, which is the unshaded area. So I think if we work out the area of this and then subtract it from the area of the whole rectangle, that's going to be a lot quicker. So let's do that. We're going to work out the area of that sector. So let's see what we have in that sector, right? We've got the side length there, which is also the radius of a circle, which is 4 centimeters as the opposite side. And then to work out the area of a sector, we need this angle here. Okay, so that's the first thing we want to do. We want to work out that angle up there. So that angle forms part of a right angle triangle. And when you see a right angle triangle, you immediately think Pythagoras. But we're using an angle. So we're not working out the length of a side. So that's not Pythagoras. We're going to use SOHCAHTOA to work out an angle. Right angle triangles and angles is SOHCAHTOA. So let's label this. The 4 is right next to the angle, so that will be the adjacent, and the 11 is opposite, with the other side being the hypotenuse. But we're using the adjacent and opposite, so we're going to use the TOA ratio. So that's the ton ratio. So we're going to start with it. Ton. The angle we're working out here is POQ equals, write the opposite first, that's 11 over the adjacent is 4. So to get the actual angle, we need to move the ton across. So the inverse of ton, 11 over 4. So let's do that. Shift ton, fraction 11 over 4, bracket. And there we go. Okay. Now remember, this is not our final answer, so don't round this. Leave a good amount of significant figures. Okay. So we got that angle there. Now we can start by working out the area of the sector. So let's do that. Area of the sector. Now if you remember this correctly, to work out the area of a sector is the same as working out the area of a circle. space here. Okay, so we have this is 4. The area of a circle is pi r squared, and then times the fraction of the circle we have in that sector, and that will be the angle divided by 360. Okay, so in this case, it's pi, the radius being 4 squared times the angle, we just worked it out, 70.0168 over 360. So let's put that in. Okay, so we got pi 4 squared times fraction, and pressing answer, it inserts that 70.0168 into my calculator, so it's more accurate, my answer, divided by 360, and that gives us 9.7762. Make sure it's accurate. Okay, this is centimeter square, it's the area of that sector. So now, if we can have the area of the whole rectangle, what is that? That will be 4 times 11, which gives us 44 centimeters square. So let's just subtract that. So 44 minus 9.7762, etc. So we can just do 44 minus my previous answer, gives us 34.2237, etc. Okay, now to do the percentage, we need to write down that 34.223, etc. divided by the total area times 100. Let's see what I can say. I can use the answer I have there and just divide it by 44 times 100. Get a beautiful 77.781, etc. Rounded to 3 significant figures, 77.8. Well done. Question 18. Read all the information very carefully. Mrs. Colley buys a jacket, 2 shirts, and a hat. So the jacket costs X. So let's write that. The jacket costs X. The shirts, remember there's 2 of them. Each one of them, so you have to multiply to cost. The cost of the jacket minus 24. Okay, these brackets are important. And then the hat costs $16 less than the jacket. Again, so this is X minus 16, not X minus 24 minus 16. Now, he spends exactly $100, so that means if we add it together, we get 100. Okay, there goes our first mark for writing down the equation. Let's simplify this. First, let's do the brackets. 2 times x is 2x. 2 times minus 24 is minus 48. Plus x minus 16 equals 100. Let's simplify it. X plus 2x plus x will give us 4x. Minus 48 minus 16 is minus 64. Then we can add the 64 on the other side. So that gives us 4x equals 164. And then divide the 4. 164 divided by 4, of course, is 41. And then you have the answer. Okay. Well done. Question 19, proportion. Let's put this whole first sentence in mathematical language. First, y is proportionate. Inverse means we're going to write it as a denominator. Square root, we put square root of x plus 4. Common mistakes here is using square or not doing inverse. Now we can make that, so that should be a 1, of course. That's inverse proportion. Then making it an equation, we put in the k constant over square root of x plus 4. We can now substitute in the values we have. Y is 2 and x is 5. Right, that will give us 2 equals k over 5 plus 4 is 9. Square root of 9 is 3. Multiply the 3 on the other side. We get k, the constant, equals 6. Now we can rewrite our equation. Remember, this is the equation over here. we can rewrite that equation, but we're now with the value k. So that would be y equals 6 over square root x plus 4. We have the value of x. We can put that into there. So it's y equals 6 over square root 77 plus 4. 77 plus 4, of course, is 81. Square root of 81 is 9. So the answer is 6 over 9. Let's use our calculator just to make double sure. Don't waste any time. Be more accurate. And there we go. The answer is 2/3. Okay. If you want to write this as a decimal, very important, you need to write it correct to 3 significant figures. So you need to write 0.667 or 0.666 and dot dot dot. Okay, or just the best way, write it as a fraction. Question 20, simultaneous equations. Even though they have lined up for us beautifully, the equal, the y's and the x's, you don't necessarily have to use the elimination method, but it's possible. There are 2 ways to do this. I think I will show you both ways. First one, let's try the elimination method. All right, we're going to have to get the coefficient of the y the same. So we're going to multiply the first equation by 2. So that will give us 6x plus 2y equals 22 over x squared minus 2y equals 18. Next, now we need to add or subtract. Okay, if we're going to subtract these 2 equations, we have 2y minus 2y, which is 2y plus 2y, which gives me 4y, which does not eliminate that y value for us. So what we're going to have to do is we're going to add it, of course. Adding it will give us 2y plus minus 2y. We eliminate the y, that's what we want. Okay, also we need to add the x squared and the 6x. We can't squeeze them together. We write them like that. 22 plus 18, of course, is 40. Let's move the 40 across because we now got a quadratic equation, which to solve we need to factorize. Okay. So let's think of 2 numbers we multiply together to give us negative 40. What springs to mind, of course, is 4 times 10 will give us 40. One of them has to be negative to give us a negative 40. I'm going to make the smaller one negative as we have a positive number because that will give us minus 4 plus 10 will give us the 6x, or the 6, which is the middle term. So multiply together, we get minus 40. Add together, we get 6. So we have the 2 factors, x minus 4, x plus 10. Set each equation to 0. That means x equals 4 and x plus 10 equals 0. X equals minus 10. I now have the 2 x values. We can write them in there, 4 and minus 10. To find the y values, we need to substitute them back into one of our original equations. And of course, that first equation is a lot more simpler without the square. So that will go faster. Okay, so let's do that. First, the x equals 4. We now do 3 times 4 plus y equals 11. 3 times 4 is 12. Subtract the 12. That gives us y equals minus 1. For the x equals minus 10, we do 3 times minus 10 plus y equals 11. That gives us minus 30 plus 11 equals 11. That gives us 11 plus 30, which gives us 41. And we've done it. Another method of solving question 20 will be the substitution method. The first thing would be to isolate the x or the y. So for the easiest way to do this is take the first equation, move the 3x to the other side. That will give us 11 minus 3x. We can now substitute all of this into the second equation where that y is there. So that means we'll have x squared minus 2. And instead of y, we got 11 minus 3x equals 18. So that will give us, multiplying out the brackets, minus 2 times 11 is minus 22. Minus 2 times minus 3x will give us a positive 6x equals 18. Let's just rearrange that. That's x squared plus 6x minus 22. Bring the 18 over. That's minus 80 gives you 0. And that will give us minus 40. You'll now notice if you watch the previous method, we are exactly where we were before. Okay, sum that up. We factorize this. That will give us x, what was it? Minus 4x plus 10. And the rest is exactly as the previous method. Please go back a few minutes and check it out. Question 21. This one looks exciting. Calculate the angle between the stick. The stick is, of course, this one here, AG or AM, and the base of the box. So it means we need to do a diagonal there, which is AC. So we've got a right angle triangle there. And what they want is the angle over here. Okay, so in that triangle, what do we have? We got 14.5, and it would be very helpful to have another length. So the most obvious thing to do here is to work out that line AC by using the right angle triangle on the base of the triangle. Okay, using the 18.6 and the 9. So this is how it's going to go. AC equals, well, AC squared equals AB squared plus BC squared. That's Pythagoras. Speed things up. We're going to square root. AB is 18.6 and BC is 9. So let's put that into our calculator. Right, so we got a nice big answer there. What is important here is not to round it yet. So put a fair amount of significant figures, at least 4, 5 is better. Okay, so now we got that line there, 20.663. We're now working with a right angle triangle, and we're using side lengths of the triangle and an angle. There we go, and that is SOHCAHTOA. So here we go. We're now going to do SOHCAHTOA in that triangle there. Let's label the sides. Our angle is here. So the 14.5 is opposite the angle. That's the O. And the 20.663 is right next to it, adjacent. Of course, the other side being the hypotenuse. But we're working with the opposite and the adjacent. So we use the ton ratio. So let's write that down. Ton, the angle, is CAG or CAM, whichever one you prefer. Okay, and we put the opposite first, which is 14.5 over the adjacent 20.663. Now let's rearrange that. So CAG equals the inverse of ton over 14.5, 14.5 over 20.663. So let's put that into our calculator. So shift ton fraction 14.5, and here, to be most accurate, I'm inserting my previous answer, which is a 20.663, just not rounded, and we get the answer. Angle CAG equals 35.05, 87, etc. Rounded to 3 significant figures. So now we can round 35.1. Question B, they tell us AM is 30, show that GM is 4.8. So we know the whole line there is 30. Let's just pick a different color here. So this whole line is 30, show that that is 4.8. So obviously we need to work out the length of AG. Now, we already have in that right angle triangle, we have two sides, the 14.5 and 20.663, so we can just use Pythagoras again. So that means AG squared equals AC squared and CG squared. Okay, so that means AG would be the square root, AC being 20.663. Remember, we had that one before. And CG being 14.5. Right, so let's put that into a calculator. Square root 20.663 squared plus 14.5 squared equals, that gives us 25.243, etc. Next thing to do would be to subtract that from 30. So 30 minus 25.243. So we can just put 30 minus a previous answer, gives us 4.756, etc. rounded. It's important to show the unrounded answer and then the rounded answer, 4.8 centimeter, to get full marks. Well done. Question 2 and 2, last one, swan song, vectors. The diagram shows a trapezium. Now, that's important, trapezium. This is the reason it's a trapezium, because remember the vectors, if two lines are parallel, like the two sides of a trapezium, the vector is not necessarily the same magnitude, but it's similar. So we know that RQ is a fraction of OP. So that means it's also the vector B. We just don't know the fraction yet. Then it tells us about A and B, and there they go, the magnitude. RQ equals 3/5 of OP, so that means RQ is 3/5 B. That's very important to notice, because when they now ask us to do PQ, all right, so PQ going from P to Q, we need to follow a route that we have, and that will be this route. And write this down, because this can gain you 1 mark. We're going to do PO in that direction. No, we're not adding. Yeah, we are calculating PQ in that direction, which is PO plus OR plus RQ. Okay, that's enough to give you 1 mark, just describing the route. So let's look at, first though, PO is B, but in the opposite direction, so that's a negative B. OR is basically just A, and then RQ, as we explained before, is 3/5 B. Just make sure your 3's look like a 3. You don't want to lose mark for writing ugly. Okay, so now we just need to simplify this. All right, so we got -1 plus 3/5. If you're not sure, should do your calculator. -1 plus 3/5, okay, gives you -2/5b plus a. If you want that, you can write that, that's fine. Or if you want to make it look like in the mark scheme, just change the negative number to the second term. And you've got it. All right, question B, a little bit harder. And I think for me, it's just difficult to explain, but the best way to do it is by using similar triangles. So hang with me. Okay, so first of all, they say they extend PQ. Let's do that. And they extend OR to meet in W. And now the position vector means we need to work out what is OW. So write this down. So we need to work out OW starting from the origin to W. And to work this out, we need to calculate OR plus RW. Okay, writing down these roots can always give you marks, so that's important to do. So what we basically want to do is we want to work out what is this vector there, OR plus RW. Okay, now working this out, that's another story. Let's do similar triangles. I'm going to split this up. There's 2 triangles. There's the small triangle, the one at the top, which is triangle RQW. And remember that RQ is 3/5. And then the bigger triangle is the W at the top and the O and the P. And if that RQ is 3/5, OP will be 1. Okay, we know they're similar triangles because they got all the angles the same. W is the same angle, and then we got two parallel lines, alternate angles, they are similar. It just tells us the smaller triangle is 3/5 of the bigger triangle. All right, so I hope that makes sense. Okay, so that means if we take RW, it will also be 3/5 of OW. So we can do the same here. This is 3/5 of this one. Or rather, okay, if we take the whole line from O to W and split it up into 5 parts, the top part, let me just make it look more realistic. Okay, this is 3 of the 5 parts. Okay, 3/5. But that doesn't mean it's 3/5 A. Okay, it's a bit more complicated. Let's remember, OR is A. And as I did this now, you can see that if I split this into 5 parts, I've split OR into 2 parts. So it means I've got a half A. That's a half A. That's a half A. And so is everything going all the way through. How many half A's do I have here? Yes, I have 5. 5 half A. So we can say that is 5 times a half A, or 5 over 2A. And that's it. That is from O to W. Okay, another way to write this is OR equals A, and RW, look carefully, equals not 3/5, but 1, 2, 3 halves of A. So 1.5 A, or 3 over 2A, which the final will be 5 half A, 5 over 2A, or something equivalent. All right, little mind bender there. Not many students got it right, but you can do it. Practice, study, listen to me, and you'll get it. That's it for today. Hope you enjoyed. Please leave comments, please like, please subscribe. See you again soon.